Good evening, ladies and gentlemen. This is WeatherBrains episode number 676. It's a Wednesday night special. This is for the 2nd of January, 2019. First show of the new year. And we're on a Wednesday night schedule this week. And I do believe we go back on Monday nights next week. We've been off Monday nights for a few weeks because of the holiday schedule here. But yeah, we'll be back on Monday night of next week. It's a ham radio special. That will be 9:30 Eastern, 8:30 Central, Monday the 7th. I know many of you might be watching the national championship college football game that night, but we're going to be right here having fun. And it looks like we're pretty much on schedule for Monday nights for a while after this week. So we'll see if anybody joins us here. And if nobody joins us, then I'll just sit here and talk for 90 minutes, and that will be something special. I hope you had a good New Year's and Christmas. The year ender we did before Christmas, so we're kind of getting our act together. See, Bill is on the line.
Yes,
on the party,
it's so
party
good to
line.
have you back home, Mr. Span.
Yeah, everybody back in the saddle. Getting ready for an exciting year of weather. So I just sent out my pick of the week, which is going to be the 17th Southeast Severe Storms Symposium. Guess who one of the keynote speakers is going to be?
Our very own Aubrey Urbanowitz.
Yes, ladies and gentlemen. That's awesome.
News.
I need to find a way to get over there and hear her speak. For years and years, I didn't miss a single symposium they put on in Starkville. And
I think in honor of JB, you should load me up in the van with no seatbelt and an office chair.
Yeah, for those that don't know, Bill almost lost his life. In fact, we all did on the way back from one of those. In the western part of the city of Tuscaloosa, Alabama, coming back from Starkville, Mississippi. And I'll raise my hand. I was driving, and Bill was sitting in the back of the van. And,
in a rolling chair.
And I looked back, and Bill was kind of like halfway upside down with his laptop in his nose. JB had grabbed this handle over there in the passenger seat. And I think you could, to this day, if we could find that van, you could still see his fingerprints on that thing.
Yeah,
He was
it looked just like John Candy in Planes, Trains, and Automobiles. And stuck his hand into the dashboard.
Oh, man.
Too classic.
No, for some reason, I thought that road was just a straight shot, and there was a little T intersection. I wasn't paying attention, and there you go. So that was special.
We really got up close and personal with a cornfield or something.
Yeah, that was that old van. That was the one that was in the Tuscaloosa tornado in 2000 with Old Shoe, and he almost totaled it in that thing. So that van had a rough life. It is retired somewhere.
I don't know. Okay, yeah, I think I've invited everybody. You can probably invite Morgan by yourself, James.
I probably can, because I guarantee you he's in here.
Yeah, I know.
Yeah, he's in
Dr.
here.
John.
Hello.
Hello. Happy New Year, Dr. John.
Same to you.
When Morgan gets on the show, it's like I feel so inadequate with my voice and everything. My hair, my voice, my appearance. He has
somebody to keep you humble.
Yeah, for those that don't know, he is the intro voice on the astronomy report. This guy.
Looking beyond the atmosphere, here's Tony Rice with your astronomy outlook.
Oh,
and he's taking the night off to be with us.
Looking beyond the atmosphere. This is Tony Rice.
Morgan, we're just bragging on you. Best pipes in the business.
If Morgan got the invite, that means everybody else did too, so that's good.
Actually, I did not. I just found my way on.
Well, that scares me because...
Oh, wait a minute. There it is, Bill. I apologize.
Well, I usually don't include all the other WeatherBrains. I just have been lately since you were having trouble. And...
Yeah, no worries.
Well, if you got it, do you see the other distinct email addresses in there?
Yeah.
And they look clear?
Yeah.
I'm on Elle's computer tonight because my computer went to the Apple store for a data migration to a new MacBook Pro.
Okay, do you hear me now?
Ooh.
Yeah, there you go, Morgan.
And is it this mic? I'm going to tap on it.
Mm-hmm.
Yes.
That's it. Good.
James, we have a pro.
Not only does he have the best pipes in the business, he has the best audio chain and the best equipment in the business.
The best professionalism, the best everything.
Wow.
This is actually, it's the same mic as the PR40, and I'm actually going through a 4-year-old MacBook Pro.
Oh, well.
But man, it sounds so stinking good.
This is probably a 4-year-old MacBook Pro too. And I've got a brand new MacBook Pro, but I don't know what I'm going to do, James, because I don't think it'll take all my USB things. What will I do?
You'll just dongles.
Get a dongle. All right. Well, they don't sell dongles at the Apple store.
This computer is
Dongles R Us or what?
Yeah, donglesareus.com. Now this computer is what year is it? 2019. Now this is 7 years old, the one I have, and I can't believe the battery still holds a good charge, and the drive is fast. The solid state drive, I've had no errors. So
yeah, I'm going to keep this thing, but I did.
Same way with me.
Thing running.
I'm going to keep this thing. I've thought about getting the new one, and this is a mid 2014 MacBook Pro, and until it dies, why get something new?
Yeah,
I think that's Apple's problem. Actually, they're making things so good, you don't need to go out there and get a new one.
So what they do is they have to remove all the ports, so we have to buy new peripherals.
Yeah, I think there was a problem announced this evening with Apple that things are slowing down, and that's probably part of the reason.
I know my stocks.
Yeah,
you're right, Maureen. That's exactly L's theory. That's exactly right.
They warned on slow iPhone sales, but yeah, like I say, I have never had a computer this long in my life, and I'm old. I mean, this thing is 7 years old. No plans to even think about replacing it.
I still have my original 27-inch MacBook Pro. It looks like a boat anchor. It's about this big, and it still runs.
Now, so here's the next set of big pipes that just got on here. Cliff is on here now, so it's like with Cliff and Morgan, we have no hope. I mean, best two voices in the weather enterprise.
This is the best firepower we've had in some time, James.
Can you hear me?
Yes, we can.
Loud and clear.
Okay, good.
Cliff, thanks for coming on the show.
Sure, no problem.
Can you guys all hear me?
Yeah, Charlie, we hear you. We see your avatar, but we hear you.
Can't see. It says my webcam's on. It's too bad. I'm seeing it on here.
What you'll need to do is go up to the settings, the little gear thing at the top, and you can choose your video source up there, and that should solve that problem. It should.
Hello, Aubrey.
Hi, how are you guys?
You're famous now.
Oh, am I famous?
Not that you weren't already famous, but you're a keynote speaker. You'll get a cowbell.
I know. I'm so excited. I was so honored to ask. I was kind of nervous.
We'll have to get our cowbells out and ring them for her.
I'm still very nervous. No. I'm thinking of calling up one of the retirement centers and seeing if I can do a dry run there.
So Aubrey, you're my pick of the week.
I saw that. Awesome.
So what is? Can you disclose your topic at least? I mean, don't give away the store, but what's the topic of the talk?
I don't have a title yet, but I'm thinking a hodgepodge of small market TV. How I got into, I mean, everyone has a crazy story of how they got into television. I have a bit of a unique story, which is also how I got into WeatherBrains. So how I got into TV / how I got into WeatherBrains. Which may have helped me get into this keynote speakership. And also I want to talk about flooding, since it has been a huge year for us flooding wise across the East Coast, across the Shenandoah Valley. And with that, I want to go into some of our big flooding events, since we are coming up on the 50th anniversary of Hurricane Camille.
Right.
Especially the Virginia part of Hurricane Camille, and a couple other big flooding disasters in Virginia. One more notably is a big flood in 1949, which is also a reason why we have a lot of our flood mitigation. It was a tropical low, non-tropical thing that just ended up causing a whole lot of flooding. Anyway, so it's a lot of flooding stuff and some Hurricane Camille wrapped into it. So it's going to be a hodgepodge of weather mush.
Now, do you have a Friday or a Saturday slot? Do you know your slot yet?
I have no idea. But I plan on going for the whole event. I told him to fly me down for the whole shebang. So
Okay,
Really?
now, do you
They're
fly to
flying-
Birmingham or
Yeah, I was actually.
Birmingham or Memphis?
They're gonna fly me into Columbus, Mississippi.
Oh, Golden Triangle, GTR. There
Yeah,
you go.
so I was gonna drive, but because I figured from my area to there, I figured it might take me 3.5 days to actually get there. But actually, it's not that bad. I think it's only about a 4 hour, even with a connection. It's only about 4 hours as opposed to 11 hours of driving. And then, so I kind of weighted everything. Was I going to stop and see a friend on the way and stop and see the James Spann again and all that good stuff. So I think I'm going to fly this time.
They never
No, that's
flew
cool,
us, James. They,
No. Now GTR is only about 10 to 15 minutes away from the Mississippi State campus. That's
Perfect.
great. A lot of times you can't really get a good option to fly in there. It's a smaller airport,
Mhm.
and a lot of times the speakers have to fly into Birmingham or Memphis. But that's great. But yeah,
did
you
you ask
were
for
my
a police escort, Aubrey, and all that?
I did. I think they're still lining it up.
Yeah.
Wow, I'm jealous. Wow.
Yeah, we see Charlie now. That's good.
You guys see me?
Yep.
Great.
Yep. Now, if we just get
here.
Dr. Reed on, we'll be in good shape.
Sweet.
All right, and again, we don't have to. We have no television live tonight, so we don't have the usual issue of having to start.
But will they?
early after, so we could actually
show
start
ever
now.
get shown on the television, James, or not? 'Cause
That's a good
Monday night-
question.
There's a real show Monday night, right?
Yes, that's a good question. I'll see if they can run it like Sunday night or something.
Yeah.
Maybe Sunday night at 8:30 Central. I'll talk with the master control operator.
And nobody will be
All right.
watching the show Monday night.
What do you mean? So I have learned in my travels that there's a lot of people that do not care about college football.
Really?
Oh man!
I don't
so
know anybody like that.
People
went
outside
to,
of Alabama.
No, nobody cares. I'd like so I was in Colorado at we went out of town for a few days, and I was in a store, and there was some other guy in there that knew me from television. He was from here, and we asked the guy running the store. He said, "Hey man, Roll Tide, War Eagle." He had no idea what we were talking about. None. I think the guy was a stoner. He was he had that glazed over
That
look in his
legalized
eyes, like,
marijuana.
There's a certain
Hey.
bulldog that knows exactly what a longhorn steer is now.
Oh, boy.
That
Yeah.
was something else.
Yes.
That was
Poor
fascinating.
Edmund really got crushed.
No, that was crazy. But no, I think that's part of ESPN's problem, where people really don't care about college football or football in general. They're just dumping they're cutting the cord, and they're losing so many subscribers, and they're having to kind of reinvent the wheel. But we'll figure out the business model. All right, 28 after. Y'all want to start, or do we need to wait, Bill?
Well, I've talked to Dr. Reed a couple times today, so I know he was going to be here. That just seems unusual. So I wrote him again, but I haven't heard anything back. So let's see.
All right, we'll
Let's see
just
if
start
I
her
can-
up here.
Maybe Colin.
Recorder 1, recorder 2, and here we go in 5, 4, 3, 2, 1. This is WeatherBrains, the weekly show that's all about weather, episode number 676 for January 2nd, 2019, first show of the new year. Aubrey, Happy New Year to you.
No, Happy New Year to you, James.
That sounds so sincere. No, we're doing this show on a Wednesday night, and we know that most of you listen, but for those that are watching live, it's a Wednesday night special. We've had, Christmas Eve and New Year's Eve and the holidays, so we're kind of off our regular schedule. We go back to Monday nights next week. But anyway, better late than never. We have not missed a week of this show in 13 or 14 years now. In fact, I want to say we started in January of 2006. So we're kind of into, what is this? We've been doing this way too long. But anyway, Aubrey, thank you for being here tonight. How was your Christmas and New Year's?
It was good. It was good. It was nice. It was uneventful, and all was well.
That's awesome. I see Dr. John. Packers are over. They're done for the year, right?
Oh, they're toast, James. And they have been toast for a while.
Yeah. So where do they go from here? Let's do football brains for a minute.
Well, there's some rumors floating around that maybe Josh McDaniels might come in and at least get an interview with them. Now, that would be very interesting from an offensive perspective.
Awesome. That would be good. So how's Rodgers doing? Is he going to stick around for a while, or is
Oh, yeah. He'll be there for a while. He didn't finish out the last game, though. Apparently he had some concussion protocol that took precedence, but just as well. He didn't need to play that game.
Yeah.
It was embarrassing anyway.
So how was your Christmas and New Year's, John?
Oh, fantastic, James. We ended up the year as we began. It was raining. So I'm sitting here, watching stuff on the tubes at 9 o'clock on New Year's Eve. It's pouring outside per usual, and we had a thunderstorm here. How about you, Aubrey?
We did not have a thunderstorm, no, but we ended with the rain. I think it was 63.29 was our final total.
Yeah, we were there, 63.35.
And you have to think, like I've said before, in the Shenandoah Valley, we're kind of in the rain shadow. So we have a lower yearly average than most places. Our yearly average is about 35 inches. So,
yeah, you are.
We're much higher on the anomaly compared to a lot of other places, minus Wilmington, North Carolina.
People are getting cranky down here. They're getting really cranky about the rain, which is kind of typical for an El Nino winter down here in the deep South. This is kind of to be expected, but it doesn't matter. People are really cranky. Bill Murray, are you cranky?
Nope, I'm not cranky. I'm glad you're back. I've gotten rid of the Russian hackers from Friday night that hacked our website.
Oh no!
Yeah, we run a blog, and we had some. Malware. What's the best word to describe it? But anytime you try to access the blog on a certain device, you would get a redirect to sexymobile.ru. Would you like to meet Russian girls? Who needs to be looking at weather? You need to be looking at us.
I'll do that, James. But
I'm excited. This is going to be a great show tonight. This is going to be a lot of fun.
The show is just thrown together. That's what's amazing, and it's some of the best.
They're the best ones. The best ones are like this.
Yeah, but tonight's guests are the brainchild of Mark Ingalls from Boardman, Oregon. He wrote us about 2 or 3 weeks ago and said, "Why don't you ever talk about the Pacific Northwest?" And I just looked when Aubrey was reading this email, and there was this hole in the show on tonight. Because we had moved all these shows around, and then all of a sudden there was this day I had done nothing with, and I was like, "That's a great idea, Mark." So, when you have your go-tos, our first guest WeatherBrain is one of those go-tos because he's got a special place in the pantheon of the show. He does the introduction for Tony Rice's weekly segment each week, and to borrow a line that Kevin Selly used when he introduced Leo Laporte several years ago, he has a voice like a basket of warm kittens. He is the chief meteorologist for Cairo TV in Seattle. Morgan, welcome back to the show.
Hey, Bill. Hey, everybody. Thanks for having me back on. It's been, I guess, a few years here since I've been on WeatherBrains, but I've seen most of you at conventions, or a lot of you, and good to be on here again. Happy New Year.
Yeah, we're excited to have you on. Thank you for joining us, and thank you for taking the night off so you could be here the whole time.
My pleasure. Take the whole day
Took
off.
the whole day off just for us, Morgan.
The whole day off.
That's awesome. And behind door number 2, we have a meteorologist at Portland General Electric. He forecasts for the utility and has done some forecasting for energy traders. Another one of the ideas for tonight's show. Charlie Phillips, welcome to WeatherBrains.
Thank you very much, Bill. It's a pleasure to be on.
Yeah, I want to learn a little more. We've never really talked to we've talked to some folks that work in the utility side, but we tend to get sidetracked on other things like giant hurricanes and
it's easy to do that. And I never really thought I'd end up in the utility industry just coming out of college. I wasn't aware that there were many jobs here, but the utility industry is full with meteorologists, and it's just becoming more and more full of it, especially as they integrate renewables into the grid. So it's definitely a pretty active field.
Well, they always say we're full of it here on WeatherBrains, so that's just perfect. We're full of it too. But that's definitely a trend that I've seen at the NWA conference every year, especially in the mentoring.
Oh, absolutely, yeah.
The energy meteorologists have an increasing share of the market, but we're glad you're with us tonight.
Thank you.
And tonight's next guest WeatherBrain is a teaching adjunct professor at the University of British Columbia. He's an expert on Pacific Northwest windstorms. Dr. Wolf Reed, welcome to the show.
Oh yes, thanks you for having me here.
Yeah, we got you on at the last second there. I was a little worried.
It's coming back from dinner.
Yeah, well, I'm sure that we should talk some Pacific Northwest food here, but we'll save the food brain segment for later in the show. And of course, last but not least, our final guest, WeatherBrains, professor of atmospheric sciences at the University of Washington, expert on the weather of the Pacific Northwest. In his book, one of my favorite books, The Weather of the Pacific Northwest, is a must-read, whether you are interested in Pacific weather, Northwest weather or not. But Cliff Mass, welcome back to the show.
Well, thank you very much.
Well, we're so glad all you guys took time out to be with us tonight. And tonight I thought we'd play America's favorite game show, Mythbusters, the Pacific Northwest Weather Edition, because I think there are a lot of myths about the weather up there. And maybe you guys can clear up some misperceptions and misconceptions about it. We all generally think that the Pacific Northwest is mild and wet, and it looks like we're all becoming mild and wet too. But agree or disagree with that? Who wants to take it? Dr. Mass? Always mild and wet in the Pacific Northwest?
Well, wet compared to whom?
Yeah,
I mean, actually, it depends where you are in the Northwest. In Seattle, we only get 37, 38 inches a year. That's less than the East Coast, right? That's the Southeast. We're drier. You want wet? Well, we have that too in the mountains. You can be up to 150, 200 inches on the windward side of the Olympics. So you want dry? We have that as well. You go into Eastern Washington and it's only 10 inches or less. So we have everything. We're just not wet. We're just not dry. We're everything.
And so, Morgan, it sounds like a real smorgasbord of weather.
Yeah, it really is. It's all about the topography up here. And what a lot of folks at the conventions ask me, what is it like to forecast for the Pacific Northwest? And these are broadcast meteorologists who, as broadcasters, we often typically just focus on our specific area of responsibility. And I say it's tedious a lot of the times. It's interesting and it's exciting, but it's often pretty complicated, and it's all about the topography. And I will second Cliff's book, Weather of the Pacific Northwest. It's a must-read for anyone who wants to learn about the weather here in the Northwest, because there are so many different facets. There needs to be a textbook on that. But as you go east of the mountains, east of the Cascades, because there is a north-south dividing line that bisects the state of Washington, it looks like Texas in central Washington or central or western Oklahoma, as you come off into the very dry areas, mainly east of the Cascade foothills on the east side.
And you get a few windstorms, don't you, Dr. Reed?
Yeah, exactly.
I mean, some of the most classic windstorms in United States history have been in that part of the country. They litter the weather history books. And you just recently had one, didn't you, here just a few days ago?
Yeah, we had a pretty good one. I'd say. Depending on what station you're looking at or whatnot, but it was roughly in some places a 2-year event, but in other places a 10-year event. Pretty good winds to the west of or east of where I live in Abbotsford, British Columbia. They had gusts to 70 miles per hour. And the last time that happened was about 10 years ago, and had a major impact on the BC hydro power grid. But there's a lot of contributing factors to that outcome relating to trees.
You really study that, and that's a big issue for us here in the Southeast. Even in just non-thunderstorm wind events. Especially with the saturated ground recently, we've had a lot of trees falling. Today and the last couple of days.
Yeah, and the saturation was a big issue with this storm in certain areas. Certainly where I live, we had. At my house, I measured 19 inches of rain in 30 days, ending on December 20th. And that included several atmospheric river events, which gave us quite a pile of rain. And Vancouver Island, large parts of Vancouver Island had excessive rain during that storm as it moved inland. And but other places, it's just like we talked about, it's topography. Other places near the Olympic Mountains, like Victoria, almost no rain fell during the storm. So the saturated soils were in certain areas, not throughout the region. And then there was this other contributing factor that we've been having. Last several summers have been warmer and drier than usual, and that has had a really serious impact on the trees. Drought stress, and this opens the door for other pathogens to hit the trees, like insects, fungus. Right, so you get these compounding events. Trees get weakened. This material has been accumulating over years. Certainly, some of it comes down every storm season. But we have quite a mass of it by this point, and I think that was also a serious factor with the December 20th windstorm that we just had. I went out and did a formal survey of tree damage in 2 parks around my home, where I went out with the measuring tapes, notebook, took detailed records of every tree that fell. And you can see almost every one of these trees was compromised in serious ways by pathogens, or they were already dead. The drought killed trees over the last 1 to 5 years. Most of these trees were in that you can tell by the state of decomposition with the dead trees, roughly how long ago they died. And so all this material came down. I had during the windstorm, I was hearing trees breaking regularly. Almost every minute it seemed like there was something. You'd hear a snap in the distance, or one of these came down next to the neighbor's house and smashed his fence, garden shed. Right, so it was quite the thing. But again, most of these trees, I'd say about 85% of them were already dead. They were victims of this drought stress that we've been having. And this past summer, by the way, I'll add for the lower mainland of BC, I was looking at Vancouver and Abbotsford, the long-term stations here. This past summer was the driest on the record when you look at May through August. And for Vancouver National, the record goes back to 1937, so it's a pretty long span of time. And it turns out being the all-time driest. That's a serious problem for our trees. Right.
So Charlie, are the utilities taking note of research like what Dr. Reed is doing with tree status and formulating that into their models of potential power outages and things like that, impacts of storms?
I'm not too familiar with the trees and actually either the power outage side as well. There is definitely a business continuity side of PGE, but I was actually out of town in Costa Rica last week during the big windstorm, and we really haven't had that many storms this year so far. So I go out of town, and then I hear that we have a tornado, and I see pictures of a big tree that's fallen down. I'm like, well, the vacation was nice, but couldn't have just waited a week or something? So
that's exactly what happens when James goes out of town too.
So yeah, I don't do too much work with that. Most of my work is centered around energy forecasting, and this is related to both the supply of energy and the demand for energy. And when I say supply, I'm mainly forecasting the power output for wind farms. In particular, I've done some solar forecasting in the past, and I've done some hydro forecasting as well. It's important to know what the stream flows are going to be off the Columbia in the spring mainly. But then there's also the demand side, because temperatures and to a lesser extent precipitation affect how much power people are going to use. And that in turn drives energy prices, which are important for PGE to know. So just a variety of forecasting, and it really affects a lot of different variables.
So Morgan, what are your biggest challenges forecasting? Because we mentioned the challenges of forecasting in the Pacific Northwest, and you're smiling. I'm sure everyone can name their favorite forecasting challenge.
The forecasting challenge that we all have here is the Puget Sound Convergence Zone. Sure, we have terrain effects. We have elevation is key in a snow event, but those are so rare. Puget Sound snow events, you have to have a lot of things going just right. You've got to have enough moisture. You have to have cold air coming out of BC, but not too cold and too fast to dry things out. But really, once we get the onshore flow off the Pacific Ocean, the airflow comes in, and it has to go around the Olympic Mountains. I explain it all the time like the Olympics are a boulder in a stream, and the water is going one way, and the water comes back around on the backside of the boulder, and you often have a lot of up and down motion, a lot of turbulence, let's say, and there's only one way for air to go when those air flows come around the Olympic Mountains and converge on the east side of the Olympics, and that's right over off in the central and North Puget Sound region from Seattle up to about Everett. Only way for the air to go is up. And that can create a very thin, snaking line of heavy convection, sometimes heavy rain, sometimes small hail, lightning. And if it's cold enough, you can have heavy snowbursts where, in some cases, a dozen or 2 dozen blocks north or south of the edge of precipitation, the sun's out. And it's difficult to predict, but you get a little better at it over time. It's all about the direction of the airflow off of the Pacific. And if there is a change in the direction, it's going to change which way the convergence zone goes, north and south. But it's often just a nowcasting, riding the radar sort of phenomenon up here that, we see in other parts of the country here and there, but it has a name for it. And since it has a name and it has been talked about so often, people come up here, especially occasionally a television consultant, let's say, and will say, well, do people really know what that is? And I say, yes, people up here, they're weather savvy and they know what the convergence zone is. They absolutely do.
So Dr. Mass, did the convergence zone have something to do with the famous tornado of a few weeks ago, the Port Orchard tornado?
No, it didn't.
Did not? Okay.
It's related to the Olympics to some degree because we had some convection that moved in. Behind the Olympics, there was an area of horizontal shear where the wind changed substantially with distance. And with any kind of shear, there's some inherent rotation with that. And so what happened was the convection came into that area of shear and then spun up the rotation and gave us that relatively intense tornado for us. It was an EF2, which is, doesn't happen that often here in the Northwest.
So how well forecast was the event and how well warned was the tornado?
Well, the tornado was obvious on Doppler radar about 20 minutes to a half an hour before. Wow. So the signature was there of rotation. Unfortunately, there were no warnings before. The models did show that there was going to be convection, so there was going to be unstable. That we knew, but there were no forecasts of a tornado, even nowcasting minutes before.
Wow. Any blowback about that from the public or anyone, or just taking it in stride?
Well, I can't be too critical because it doesn't happen that often. So maybe some of my colleagues in the Weather Service weren't, quite ready to put out any kind of warning of a tornadic activity. But the signature was there. I think if you pulled someone from the Midwest and they were looking at that radar screen, they would have suggested that people downwind might have gotten ready.
Well, Morgan had the first draft choice there on our weather fantasy draft. So what would you say is the second most important local effect that you have there that you have to deal with in forecasting, Dr. Mass?
Well, the most damaging weather phenomena here in the Northwest is heavy rain, atmospheric rivers. So, the $1 billion disasters are all those, right? Mm-hmm. And so there's a number of us working on improving forecasting on that. So that's the number one phenomenon. But actually, the number one killer is black ice. Ice on the roadway is the most prolific killer and injurer of people in our region in terms of weather.
Was that a contributing factor in the Husky bus crash before the Apple Cup a few weeks ago?
Right, there was some freezing rain.
10 minutes to show. 10 minutes to show.
That's what did it.
Sorry.
So that was a freezing rain event, but you can call it ice on the roadways. So if there's no weather phenomenon that's even close to either freezing rain or ice due to fog in terms of killing and injuring people in our region.
And that's what we really have up here in Western Washington, west of the Cascades, and it's the freezing fog. We have it so many mornings this time of year, and we have so many rural roads that are 2-lane roads that are winding, and it's just it's awful. And people know to slow down, but if you're on your way to work and our sunrises are so late here this time of year compared to other parts of the country down south, there are so many people driving in darkness that might be drowsy or in a hurry. And it's a tragedy that happens over and over again.
James, maybe we're becoming Seattle because we've dealt with freezing fog. It's been raining for days. What's the deal?
Well, next year.
Start growing a couple mountains down there, and
So Charlie, beyond that, you mentioned gap winds when we were talking before the show. Talk about what those are all about.
Well, I grew up in Seattle, and I went to the UW and took classes from Dr. Mass, so I'm very well acquainted with the convergence zone and atmospheric rivers and windstorms up there. But living in Portland now, I've become very familiar with the east wind that goes through the Columbia River Gorge, and it's really a sight to behold. I mean, there are periods in the winter where you'll have strong gusts in the Portland metro area, 30 to 40 miles an hour for the better half of a week, sometimes persisting into 5 or 6 days at least. And then if you head a little bit further east towards the western exit region of the gorge, kind of by the Cascades there, but still a little bit west of the Cascades, that's when you get your strongest winds. And there's this one point called Crown Point. And that place is notorious for getting very strong winds. You'll see people go up there with handheld anemometers and register triple-digit gusts on those during those, and it occurs for days on end. What happens is you have a large stagnant ridge of high pressure over the region, often in the same kind of scenario that will give you fog in more sheltered places like southern Puget Sound. But it doesn't happen in the Columbia Basin it doesn't happen in the Portland metro area because you get those strong gap winds. What happens is you get a cold pool of air in the Columbia Basin, and that leads to surface high pressure and very strong offshore gradients. You get that air that goes through the Columbia River Gorge. It accelerates when it gets to the western exit region of the Columbia River Gorge and gives the Portland metro area, and especially regions just a little bit to the east, to those extraordinarily strong winds.
I mean, Carbon, tweeted out a map of, all the rainfall for the year across the United States. And, everyone had a lot of rainfall in the east, but, Washington and Oregon were, far away and beyond anything that anybody else in the east had. I think 250 inches and 150 inches. Where are those stations? And are they, situated on the west side of the Cascades? Is that where that happens?
That would mainly probably be the Olympics, the southwestern slopes of the Olympics. Cliff can talk a little bit more about this, but there was the Olympics project where they actually measured rainfall on the Olympics and verified some of the estimations that were based before. But yeah, they get tons of rain over there. A lot of rain in the Cascades as well, and on some of the volcanoes, the windward slopes of the big volcanoes like Mount Rainier.
Well, one thing that's important, we not only get tremendous amount of rain on the windward slopes, but then we have the lee rain shadows. So
yes,
we have the greatest precipitation contrast in the United States. I mean, on one side of the Olympics, you can have 180 inches. 40 miles away, it could the annual precipitation might be only 15 inches. So it's huge contrast. Squim is a place on the.
I was going to ask you about this.
That all these people are retired to. People from California. We have California we have Los Angeles precipitation here in Washington State in Squim, and so it's just startling how dry it is there. There's cacti there. And that's
you call this the blue hole of Squim, right, Dr. Mann?
That's right.
And that's because of subsidence causing clearing there faster than in areas around it.
Right. Well, there's subsidence. I mean, basically, there's a large mountain wave on the Olympics, and there's huge subsidence sinking down on those northeast slopes of the Olympics, and then it desiccates it completely. It's so it's dry.
It looks beautiful there.
Talk about mountain waves. Those are fascinating to us because we don't get to see them or be around them. Who wants to talk about mountain waves for a second?
Well, from a wind forecasting perspective, they are our kryptonite. They are so annoying. Wind forecasting is already tough enough. And most of our wind farms are actually the eastern exit region of the Columbia Gorge. So I talked about the strong easterly winds coming through that are just a little bit east of the Portland metro area. Well, in the summer, the primary wind is from the west. The Columbia Basin heats up, that lowers the pressure there. Instead of getting that cold pool and the high pressure that you see in the winter, you get lower pressure there as it warms up during the day. And that triggers a positive onshore pressure gradients, and you see an onshore push, and you get the strongest winds just to the east of the Cascade Crest. And that's where a lot of those wind farms are. But as the winds go over the Cascade Crest, you'll see some of that mountain wave activity. And that mountain wave activity is most pronounced actually during the winter, I would say, and during when a lot of our storms come through. If you have a stable atmosphere, especially ahead of a warm front or something like that, and you see, I guess the best way of just putting it is that you can see swings from no power to full power in a very short period of time, because these waves can go down to hub height at turbines, and you can see very strong variations in wind speed over a very short distance.
Well, there's one mountain wave story that a lot of people may not realize. The mountain waves here started the UFO craze in the United States.
Really?
Really?
It's not well known, but in 1948 there was a mountain wave off of Mount Rainier produced a lenticular cloud, and a pilot that was going across the Cascades saw this rapidly shifting lenticular clouds and thought it was some kind of UFO. And so actually the whole UFO craze started here.
Interesting.
That is amazing.
Known, but we get credit for that.
So talk about the physics behind what makes them happen. What's going on in the atmosphere that causes them to occur?
Well, the physics is pretty simple. I mean, if you have air approaching a mountain crest, or let's say Mount Rainier, it's forced to rise. As it rises, the air cools, saturates, you get a cloud. And then when it comes down the other side, it warms and the cloud evaporates. So you can get a primary mountain wave over the cloud. But then if it's a stable atmosphere, the air will go up and down. And when it goes up, you get the lenticular cloud. And when it goes down, it goes away. And so, we see lenticular clouds all the time here, and some of them do look like UFOs, and sometimes they can shift relatively quickly.
So are they rather passe in the process, or do people still get excited about them when they see them?
Well, sometimes they're stunning. I mean, sometimes they're extraordinarily beautiful. Sometimes they're stacked in plates.
Right.
And I just had it the other day over Mount Rainier. We had 3 of them were stacked on top of the mountain, and it's extraordinary.
And they're not always, but they're often a sign of an incoming storm system. As the atmosphere begins to moisten up, especially at the mid-levels, we start to see lenticular clouds. So it doesn't happen all the time, but often if you start to see them in the afternoon, the next day or the day after, you'll have a system coming in off the Pacific.
Right.
So Morgan, we're commissioning you to create a piece of weather folklore for us there.
Yeah.
I think a lot of people have done that a long time before me. I heard that when I got up here.
Yeah, that's pretty funny. Talk about the Brookings effect in Southern Oregon. Who's got some familiarity with that? Because
I wrote a paper on it.
Not with that. Here we go. Expert.
Well, that's another amazing anomaly. If you look at the terrain of the West Coast, there's something very unique about the very northern part of California and Southern Oregon. The Siskiyou, Klamath Mountains go all the way to the coast. And so if you get offshore flow, you can get this tremendous subsidence there around Brookings in that area, which is a town just north of the California-Oregon border. And you can get unbelievable warmth. In the middle, it can get up to 80 degrees in the middle of February as the air sinks down. And so we've seen a number of cases where it could be 80, 85 there and go a few miles north and it's 60 or 50. So that's the Brookings effect.
So Dr. John, I see you over there like me. You're writing down all these places for retirement. Are you? Which one are you going to take? Dr. John's muted.
You're muted.
You're muted, Dr. John. Unmute thyself.
Sorry, all my clocks are going off. It's 10 o'clock in the east. But what I was saying was we don't see a whole lot of lenticular clouds in Pennsylvania. So I wouldn't mind retiring to a place where I can see that on a regular basis.
Mm-hmm.
I don't even see the satellite pictures all the time. It's
Not quite the same.
Off of the Appalachian.
So what is it like, Morgan, to look out every day and see Mount Rainier? I mean, that just the one time I went to Seattle, it was amazing to me. It dominates the sky.
It does. It dominates the skyline. The farther south you go toward Tacoma, the bigger it gets. It's amazing that is. I mean, its prominence makes it so incredible. The fact that you go from sea level to 14,000 plus feet, and it's just so close to a heavily populated area. I see it most days, or a lot of days, if it's clear. As I'm driving across the I-90 floating bridge across Lake Washington, going to and from home, it's just stunning, and it's incredible at night or at dusk. Or at sunrise as well, but especially at dusk when you're looking back from Seattle and you already have sunset, but the summit of Mount Rainier will be just glowing orange or pink, and it's pretty spectacular.
All right, I'm booking a trip.
Yeah,
one thing I saw this is actually Mount Hood, but one thing I saw that was pretty cool a couple months ago was it was sunrise and there was a shadow at just the peak. And I've seen lots of pictures of this before on social media. People have posted around, but you could see this shadow stemming all the way from Mount Hood back hundreds of miles, and it was the only shadow around. Everything else was illuminated. It was really cool to see at sunrise.
And
I tell people this is the most beautiful place in the world when the sun is out. Not most of the year. A lot of the year. Today, it was just gray most of the day, and so we get that this time of year.
So best time of year to visit.
Late July, early August.
July 5th.
July and August.
So 2 weeks of summer.
Well, a lot of people say that summer in Seattle begins on July 5th.
Yeah,
because we often have June gloom. Haven't had as much of it over the past few years, but we often have a lot of persistent gloominess in Puget Sound in the May-June timeframe. So you get past the 4th of July, and then the weather turns nice.
The weather service says July 12th.
It's like the monsoon in Arizona. And there was a tremendous storm on Mount Rainier in 2006, wasn't there, Dr. Mass? I remember visiting there and there being still signs of it in 2011 or 12.
Well, on Mount Rainier, or are you talking about generally in the area?
It may have been a larger storm. I just remember there were effects of it everywhere.
I mean, we did have a big storm, general big storm in 2006.
That may be one of Wolf's storms. Which one is that, Wolf?
Yeah, Wolf will know all about that storm.
Tell us about it, Wolf.
Yeah. Well, the 2006 December 14th and 15th.
It's called the Hanukkah Eve storm.
Evening, and the Hanukkah Eve storm is what it ended up being named. And it was one of our major windstorms. It produced probably the strongest wind gusts at SeaTac Airport since the Columbus Day storm of 1962, which is the benchmark windstorm. And but it's hard to tell. There's been a change in instrument methodology between events, and so it's kind of hard to say, well, was where the storm fits within the long-term methodology. It's a little bit difficult, but I would estimate that wind gusts, instant wind gusts, as you might see on an old analog anemometer with a direct reading dial, probably were in the range of 80 miles per hour at the SeaTac Airport at the height of that storm, and it's very significant type of event. The way I like to think about it is when you think about tree physiology, there's a critical threshold of wind speed where you start seeing a large number of tree failures, and it's it's between the 50 and 60 mile per hour range for most trees. And so once you start pushing above that margin, right, you start seeing more and more tree failures. So when you get a windstorm with 65 mile an hour gusts, it's noticeably more impactful than, say, one with 55 mile an hour gusts. When you're talking 75 to 80, the tree damage can be truly spectacular. I mean, you get widespread loss of trees. And so the Hanukkah Eve storm was reaching that in certain areas, including SeaTac Airport. Up here in Vancouver, British Columbia, there was a massive blowdown in one of our key parks. They lost thousands of trees in a massive swath as the storm came through. Unfortunately, there were no instruments near this area, so we can't say exactly how strong the winds were. But just eyeballing it, I would hazard a guess. At a minimum, the wind gusts were 80 miles per hour through that park.
Wow.
And it was the largest blowdown since the Columbus Day storm in that park as well, marking a storm of significance. You're talking it's at about a 40-year event in that park, right? So it was a key windstorm, and it was also a very big storm. It reached well into northwest Oregon. It struck the Willamette Valley pretty hard. Even though it tracked across, southern Vancouver Island, it wasn't a very close track to Oregon, but it still delivered a noticeable blow to that state as well. So, I wouldn't be surprised if you saw damage, from that event even years later. It caused quite a bit. In fact, you go to Stanley Park up here, even now you can tour around and see the blowdown zone. It's now growing in. Our vegetation actually, it fills in quite rapidly. We have fast growth rates for certain conifers. And so you go to Stanley Park now, and what we're looking at, how many years here? 14 years ago. Trees are pretty tall. The new growth is getting pretty tall in some areas.
Well, Mark wanted us to ask, because he's the benefactor of all this brain power tonight. He wanted us to ask you to talk about the difference between, these windstorms and tropical cyclones that we deal with, in other parts of the country and world.
Well, okay.
Is this for Cliff?
Both of y'all, everybody, free for all.
I'll let Cliff go first too.
Well, our strongest storms can be equivalent to Category 1 or 2 hurricanes. Our strongest storm in the last 100 years was probably the Columbus Day storm, and that was probably the strongest extratropical cyclone to hit the United States in that period anywhere in the country. So we can get some pretty big storms. One thing about our storms is they are much larger. Hurricanes are small compared to our big cyclones, so you never should forget that. And the other thing is the trees. The trees are tremendous force multiplier here. If you're in Florida, if a palm tree falls in a house, who cares? But when you
Does anybody hear it?
When you get a 120-foot fir coming down, it slices the house in half. So you should never forget that the big trees here make the damage way, way worse.
So many of our just standard windstorms up here in the 45, 55 mile an hour range over the last number of years, especially the first one of the season, there almost always seems to be a fatality, either in a home or a car. It's so unfortunate, but a 50 mile an hour wind is no big deal when you're talking about a tropical storm. Everyone's driving out in it, but here tree limbs are coming down, roads are being barricaded by all of the foliage, and it's incredibly dangerous. And it starts very quickly. That's the thing a lot of people are surprised about. Okay, it wasn't windy all day, and the topography has a lot to do with this in Western Washington. Okay, it's not windy at my house. You said it was going to be windy, and 10 minutes later they're tweeting me, "Oh wow, it just hit," as the winds very subtly shift direction.
I'll add. One of the key, issues with all these big trees is that just what he was talking about, they block key lifelines, right? You get massive trees blocking roads, covering railroad tracks. You're cutting off the ability of crews to come in and fix power lines. You're cutting off the ability for emergency medical responders to get to places. Because it takes time. If you have a 1 meter diameter Douglas fir come down, it takes time to cut that and move it off the road. It's a lot of wood. It's heavy. It's not something to be done quite easily, and so it is a problem. And then I'll add, to some of the Columbus Day storm. When you look at its impact in Northwest Oregon and especially the Willamette Valley, where they were wind gusts to 127 miles per hour were clocked, like in Corvallis, Oregon. And then the wind instrumentation failed, and the observers then said the winds continued to increase for another 15 minutes after that gust measurement. Okay, so we're not even talking about the peak gust of the storm, really. The impact on the infrastructure was phenomenal. The power grid quite literally had to be rebuilt from the ground up. You're talking 99% destroyed by this storm, and this is 1962. And I'm always left wondering in this era, where we're even way more, we're far more dependent on electricity than we were back in '62. What a storm like this might do, right? It's a serious thing to think about.
Yeah, Aubrey, are you taking notes over there, changing your topic for the Mississippi State program? You might be.
Well, I've
great
already
windstorms of the Northwest here.
Well, it's incredible. John mentioned the benchmark nor'easter in 1962. In the Shenandoah Valley, 1962, that nor'easter was our biggest.
And it's the year I was born, so it had to be important.
It was one of our biggest snowstorms here.
So has anybody gone back and studied the patterns, the global patterns that might have resulted in that? Was it just coincidence, Dr. John, or was there something going on in 1962? Atomic testing or something?
Oh, sure, Bill. That's what it was. In fact, it was contrails. It was all contrails.
Yeah, it was the chemtrails, I bet.
Chemtrails. Thank you, James. You got the cue. Now we forget that Sandy produced record snows in West Virginia.
Yeah,
that was coming in.
Yeah.
So we've had some far-reaching impacts from coastal events here in the east. But the March '62 storm, I actually remember that. I remember going to the coast to look at some of the damage. I was 5 years old at the time, so you can do your math. But I was pretty young at that time. But I just remember seeing this. The collapse of the buildings right along the coast. And that was just a 48, 72 hour nor'easter. It was unheard of. Still is, actually.
And that's the Great Ash Wednesday storm, right?
That's it. March
the
of
Ash
62.
Wednesday storm. And how long did that affect the Pacific Northwest? Was that a pretty fast mover, or was that kind of a slower storm?
Well, the Columbus Day storm was fast. It came in. It was a classic. The wind, once the setup was ideal, the winds just kicked on in a near instant. Like you're talking about maybe over a 15-minute period. You're going from moderate wind speeds to extreme. And then they usually lasted about 2 to 4 hours at any one location. And it just swept from south to north. It first hit Northern California and went straight up the coast into southwest British Columbia. And it essentially, it set pretty much every peak gust speed record there is for any of the official stations.
Wow.
There may be 1 or 2 exceptions to that, but it pretty much still has all the record speeds.
And where did it rate in terms of barometric pressure and where in the pantheon of the great storms?
Well, the central pressure was down to something a bit below 960 millibars, maybe around 958, if I'm right. I'm trying to remember. It actually wasn't the deepest of the big extratropical cyclones. Another one, what we might call the little brother or the little sister of the Columbus Day storm, November 14th, 1981, had a central pressure down to 947 millibars at its peak. And this, of course, the local weather stations on the coast will get most of that, right? The minimum pressure at Astoria, Oregon during the Columbus Day storm, I think, was 28.62 inches. It's not the lowest that we've seen storms with lower. A storm from history, far history, by the way, would be the January 9th, 1880 windstorm that hit the Willamette Valley and coastal Oregon. And in Portland, Oregon, they had a minimum barometric pressure of, was it 28.56 inches?
Wow.
And on the coast, it was almost certainly lower than that. And that storm, I would say, was perhaps a near equivalent to the Columbus Day storm, based on the damage reports for the Willamette Valley. Now, in Western Washington, because the track was into Northwest Oregon, Western Washington was spared the winds. They didn't get any winds, but they got a lot of snow. Right?
I'm looking at a newspaper headline from 1962, and the headline says "Hurricane Devastates Oregon."
Yeah, exactly.
Yeah.
Yeah, well, there's in some circles the storm is referred to as Typhoon Frida.
I saw that, and the big blow.
Yeah, the big blow, the terrible tempest of the 12th.
Yeah, a lot of our significant windstorms up here in the Northwest have a connection to the West Pacific and typhoons. Okay. And there is often a misconception. I got an email a few years ago when we had a storm developing off the coast. We're getting hit by a typhoon. And so, I've got to be very careful mentioning the word typhoon because the remnants are involved, and just give it that extra punch.
Yeah, and that's what happened with the Columbus Day storm. The remains of Typhoon Frida were involved with the storm formation, and that name stuck. And so in certain areas, like you'll find people referring to it as Typhoon Frida and in parts of the Willamette Valley.
They were naming storms before the Weather Channel named storms. How about that?
I thought it was some grocery store.
We're on to something back in the 60s.
Was coming up with these great things.
There was actually a storm that was that made landfall. I think it was 2016. They called it the Ides of October storm. The Weather Service called it, but it was born out of Super Typhoon Songda, also in the Western Pacific, and it had a similar setup to the Columbus Day storm in many ways, but it and some models were showing it being quite strong. But it actually was much weaker than originally feared. So the media played it up and then they tried to calm it down, but
it was a communication disaster.
Out of the hat, it's hard to go back.
Well, it was, and if I can step in real fast, because it was really a problem because the talk and it didn't start with the National Weather Service. It didn't start with the media. It just sort of started. A combination of social media, National Weather Service forecast discussions. We're talking about it. And this frenzy started to build up. And it was the first time that I have encountered in the Seattle market something where the communication and the messaging got away from everybody really fast. And there was no way to go back. And it turned out to be on a night when there were a lot of, I believe, homecoming dances, a lot of things that were planned, and everything was shut down. And it just didn't perform. The storm did not perform as expected. And you want to talk about blowback. There was blowback, big time.
Yeah, well, I'll add, it was an interesting, in the models, looking at the models, us mainly following the WRF GFS from the University of Washington, but it seemed like as we got closer and closer to the storm event, the storm kept shrinking. Yeah. In fact, I remember somebody making a joke that, by the next run, it won't even be around. It's just gone. And so what happened was it ended up having a really compact core. And so places that ended up really close to that core, as it tracked in near Tatoosh Island up on the northwest tip of the Olympic Peninsula, they did receive some pretty intense winds. And that also includes parts of southern Vancouver Island. But most of the region just did not get hit by the most intense pressure gradient zone of that storm. So it wasn't a big, large-scale event like the Columbus Day storm or November 1981 or the Hanukkah Eve storm. It was a way more focused. It was in some ways it was almost like a hurricane. It had a very compact core, and if you were too far from that, 100 miles away, you were not in the zone to get the extreme winds.
Well, it was a good example of us not, explaining the uncertainty in the forecast well enough. I mean, there were a few model runs that a week out were going for the storm that was the equivalent of the Columbus Day storm. Now, then the Seattle Times did a big front page story on it. But the truth of the matter is, we're really trying to do it. You're taking a storm that started 5,000 miles away, taking it across the Pacific, trying to forecast its phasing with an upper level shortwave just perfectly. I mean, it was just impossible to get this all right. The uncertainties were huge, and we never communicated that well. And since then, we've developed the technology of high resolution ensembles, and which we've built now at the University of Washington, and we're hoping to avoid that in the future by telling people what the uncertainty is about. That's the future of forecasting.
I agree.
Yeah,
I agree.
Yeah, I'll add, like when I see a very low probability event being shown by the models, like a Columbus Day storm might be a 100-year or 200-year event. I immediately look at it with extreme skepticism. Right, if it's a low probability event, just climatologically, you got to pause and go, okay,
yeah,
let's gather more information before we jump on this solution here.
Yeah, and unfortunately, those are the images that get shared all over social media and lead to the hysteria.
Exactly.
With the Ides of October storm
But now we have the ensemble systems, and if you do a search on Windwatch, something we developed for Seattle City Light, you can see an ensemble there of all the forecast winds over the city, for instance, and you can see what the uncertainties are like. And you can look at it for the windstorm we're expecting tomorrow. So I think the technology has come a long way in the last 5 years, and we just have to find a way to communicate it.
Absolutely, yeah, communication is huge.
So I have a question. If you were living around the Great Lakes or the upper Midwest on November 9th and 10th of 1975, the storm of memory there is the Edmund Fitzgerald storm. But that's also a big event. That date was a big event in the Pacific Northwest. So where does that coastal storm rate? November 9, 10, 1975.
Well, is that the one? I'm trying to blank. That's the one that hit Southwest Oregon, right?
Yeah. 975 millibar.
Yeah, that one. That one was quite interesting for its intensity, like from among all the windstorms I've analyzed, looking at the pressure traces and whatnot. I think that one produced the largest hourly pressure jump I've seen from any windstorm, and I cannot remember the exact figure, but it definitely looked like something from a hurricane.
Wow!
It was in that magnitude. And again, it was another storm that was very focused. Anything just immediately to the south of the low received a very serious blow, including Roseburg, Oregon, which is in a very sheltered valley. It's a very narrow valley. They're often the least windy official weather station on the west side of the Cascades in Oregon because of that sheltering. But they managed to eke out a 75-mile-per-hour wind gust from that storm, and it's the highest in their record.
Wow!
So it was a serious event. It was another fast-moving, rapidly intensifying extratropical cyclone. There was some worry. I remember that forecasting then wasn't as good as it is now, and I think there was some worry that it was going to hook up the coast and follow a track similar to the Columbus Day storm. So I believe there were wind warnings issued for Portland and places north, but the track was more northeast, and it just went right across southwest Oregon. And it went just south of Eugene, which is at the south end of the Willamette Valley. And they were getting strong northerly wind gusts up to about 40 miles per hour. The low went just south of them. So essentially a track between Eugene, Oregon, and Roseburg, Oregon. And there's not a huge distance between those two stations.
Wow.
So Eugene's getting northerly winds, and Roseburg's getting southerly winds. Fast. So it's quite interesting.
So I'm going to share your analysis, Wolf, right now.
Oh, there we go.
There it is, right? That's the storm you were just talking about. The grading is just spectacular with that.
Wow.
Yeah, and again, there's this. We can always keep cutting things down into different fine categories, but I do keep a specific category of windstorm, which is a rapidly intensifying low that makes landfall at or very near peak intensity. And that's one of the, what I call one of the hallmark events that I use to assess windstorms, if I'm going to put them in that category. So that's a classic example of it. There was another one in 2002, February 7th, that was very similar. Did not get as deep. It was about a 994 or 993 millibar low, but it landed in Southwest Oregon as it was rapidly intensifying, and it tracked just north of Eugene. And so Eugene was right in the main high wind strike zone, and they got hammered. Official wind gusts, 5-second average was 70 miles per hour, which again, I would estimate 80 to 85 miles per hour for shorter period gusts. And the damage was phenomenal. I went down there and toured the strike zone, and there's only one storm I can think of that I personally experienced that had even higher damage than that one. That was a coastal wind storm in 2007, but the amount of trees down was quite high, and also just the structural damage from the raw physical wind force. Just excluding trees from looking at the roofs being partially broken off, siding peeled off the houses. That's where you're starting to get into more interesting winds, right? And they're not very common. They're not over here. They're not that common. But so those were the highest wind gusts in Eugene since Columbus Day storm. So it was a 40-year span of time. So it was a significant storm. And again, I guess that going on the forecast side, the interesting part about that event was that it also caught forecasters by surprise. They were not forecasting a high wind event in the South Willamette Valley ahead of that storm, and they didn't really clue in until it hit the coast. So when the effects of in Coos Bay, Oregon, Brookings, all on the south coast there, were evident, they're going, okay, this storm's a bit stronger than we were expecting. Then the warnings started coming up at that point. But it might be one of the last examples of a surprise windstorm from an extratropical cyclone in our history. Knock on wood, but it might be one of the last.
Well, let's hope so. Dr. Matthews, you mentioned flooding being a really serious threat. To talk about the Huebner Flood, what made it different?
Well, that was convective. That was associated with some heavy thunderstorms, relatively stationary in the Blue Mountains there. So at that point, we didn't have weather radar, obviously. That was back around 1900, and so this surge of water came down and basically destroyed the town. So, we have seen other flash floods. That it's not unique. There's one that happened near Yakima more recently. So we have those every once in a while. If you have heavy rain in the hills and the precipitation just collects in streams and just surges into a town. That's a Northwest tradition.
Yeah,
it's amazing.
You could kind of say there was a flash flood in Seattle, and I just remember this very vividly. It was the evening before the Hanukkah Eve storm. There was a very heavy band of rain that stalled over central Seattle, very close to my house, near the Madison Valley neighborhood in particular, and it dropped around an inch of rain in an hour. I had a cheap weather station at the time. I was in 8th grade, and we measured rainfall rates of around 2 to 3 inches an hour at the peak of the storm. So
it was about an hour, and a woman died in her basement.
She did, yeah. She got, because Madison Valley is shaped like a bowl, so all the rain that was within that mile radius or so just all flowed down, and she was unfortunately at the bottom, and she got trapped in her basement as the floodwaters came and rose. So that's the example I can think of a flash flood in Seattle. But even our Pineapple Express atmospheric river events, they aren't technically flash floods, but the rivers Once when they flood, it's absolutely incredible. Wolf talked about the coastal storm in 2007. That had incredible flooding over mainly Southwest Washington, Northwest Oregon, and then also the Olympics. But the Chehalis in particular, it flooded I-5. I think covered it in like 10 feet of water for the better half of a week or something. So yeah, I mean,
that Chehalis flood. When you look at the long period record of the stream gauges, that Chehalis flood was off the charts. So
There's
no previous event that would even clue you in that you could get something of that magnitude on the river. It was truly a phenomenal atmospheric river event.
I think looking at some of the stream gauges I've seen, Chehalis River crests, I don't know, 23, 24, 24, 24, and then like the 2007 storm was like a 31 or something ridiculous, just completely out of left field. I mean, yeah.
It's way up there.
Yeah.
I'll add that my sister lives in Bremerton, and her home's kind of on top of a rise, right? So they don't worry about flooding, right? But there was so much rain fell in such a short period of time in Bremerton from that event that their basement flooded, even though they were on top of a rise. Okay, and then so she called me. I'm just wondering, is this going to be a common thing, or? And I said, no, that's you just went through a historic storm, right? That's not going to be a common event.
And the urban drainages in the cities in Seattle and in Bremerton and the rest of the area, if you're in an urban area, they're not designed to take significant convective rainfall. Our drainage systems are designed to take rainfall, but only, 1/10 of an inch over a few hours, and not, an inch an hour rainfall. Also, when we have especially atmospheric river events coming in the early part of in the fall season, before a lot of the deciduous trees have lost their leaves and those leaves are gone, we can get really significant urban flooding. Neighborhoods that just fill up with water because the storm drains are clogged with leaves and debris. And until all that dies out and decays, that's a problem that we continue to stress, that people are driving around at night and they're driving into their neighborhood and all of a sudden they're driving into water that they're not expecting to be there.
Yeah, exactly. In fact, that just happened up here in Vancouver in October 19th. We had a 2-hour rain event. It was about 1 to 1.2 inches total, and it was October. Lots of leaves down. The storm drains got plugged up, and there was widespread urban flooding. This was at night, so it was catching a lot of people off guard. So there was a bunch of cars that got stalled out, in 1 to 2 feet of water. Plus, there's a lot of these low and mid-rise condo buildings where they build underground parking garages, and several of these parking garages flooded, where the water just went down in them, and the drainage systems couldn't handle it. And so that was it was a bit of a surprise event too. That wasn't, it didn't really get forecast well up here, I don't think.
Yeah.
It's kind of a convective type rain event. And but also I was thinking, I'm particularly intrigued by the rainfall patterns we see with our atmospheric rivers, and I looked at I've been studying the 2007 event in detail off and on when I can find the time. And I was looking at the Bremerton Airport, the Kitsap County Airport readings, and it's really, you get this really neat pattern as these atmospheric rivers are moving in, where the rain starts off light, and it just slowly builds and builds. When you're looking at, say, hourly rates, start off light and then get up to the moderate, and just builds and builds and builds. And finally, it reaches this peak threshold where you have the best dynamics for rain. And for Bremerton, it was about 7/10 of an inch an hour, 6 to 7/10 of an inch an hour. And it just kept going and going and going. And then when the boundary finally moves through, which takes on the form of a cold front usually, the rain just shuts off in an instant, right? It goes, and then all of a sudden you're to zero, because it's now south of the region or whatnot. But so at Bremerton, there's some discrepancies in the data, but I think they had at least 7 3/4 inches of rain from that event, and most of that fell in 12 hours.
Oh.
Right. So that was a real rain, and this is a lowland station. When you get into the Willapa Hills, in Southwest Washington, the rainfall was much higher than that. Unfortunately, there's not a lot of rain gauges out there where you can get high resolution precipitation data, or they're privately owned. Like I know Weyerhaeuser Company has some, but getting the data from them it can be a problem. But their rain gauges, by the way, reported some pretty. I can't remember. I think one of them might have indicated 19 inches for that storm.
Oh, wow!
Some might be like a 24 to 36 hour rain. Which is pretty extreme.
Dr. Mass, I know you have to go here in just a second. Any last thoughts? Anything you want to make sure we mention before you leave?
Well, you didn't talk about wildfires.
I know. It's right here on my list. I think we're going to have a part 2 of the show. This is just terrible.
Issue right now. I mean, that's become smoke in the summers has become an extraordinarily important societal issue. And so that's the new horizon for meteorology, is dealing with the wildfire threat.
2 years in a row of ash falling from the sky in the immediate Seattle area. And it was surreal.
But just the air quality problems, the health effects, smoke found. I mean, so it's just not ash. It's just the people getting sick, all over the whole region, and the psychological effects of all this smoke and everything else. So that's huge.
Yeah, and by that, there's been like a switch, right? Like in the past, say before 1985, for the Pacific Northwest, our smoke season was the winter, when everybody was like burning their wood fires, and you have stagnant conditions, high pressure over there, temperature inversion, and you have massive smoke buildup and smog built in the cities. Well, that got largely cleaned up, with gas fireplaces and whatnot. And now it seems like we're getting the smoke season in the summer.
Yeah. But that's historical around here. If you go back 100 years, this place was very, very smoky during the summertime. And
exactly.
So we got away from that by suppressing fires and whatever, and now it's coming back. So we're returning to our roots, and more attractive perhaps.
And we have a lot more people living at the woodland interface and wanting to live there. And that causes all sorts of problems, because a lot of our fires are caused by lightning, but a significant number in the past few years have been caused by people.
Right.
Yeah, I saw a statistic in British Columbia. It's for 2018, I believe it was 47% were human caused and 53% were lightning. Was the breakdown up here. And we had we had over 600 significant wildfires during the season. It was truly a phenomenal wildfire year, with about 1.3 million hectares burned.
Wow.
Some of them have to convert that to acres or square miles, but that's the statistics I saw up here. And it was either the second or the first greatest area burned on record. And you guys were getting our smoke, in part.
Yes, we were.
You were.
In fact, this past year wasn't a terrible fire year in Washington State. Yeah, it was not very significant. We got smoke from Oregon, and we got a lot of smoke from British Columbia. Sure, we had some fires around here, but it was a 1-2 punch from the north and the south. And I had people yelling at me, why can't they just go put out those fires up in British Columbia? I'm like, okay, we have a fire 20 miles away from Seattle, and it might burn for days. Try to get up into the Cascades of Washington, especially up in British Columbia, where you have a lot more wilderness area.
Yeah.
It's impossible. It has to burn itself out, and that might take months.
Well, we're sending you right.
Wait for the rains.
You'll be set.
Yeah, exactly. In fact, there was a point, because there were because of the extremely dry summer we had, as I mentioned earlier, there were fires on northern Vancouver Island, and so we were getting smoke from those too. And so I remember one of the National Weather Service people in Seattle was saying that there was essentially only one wind direction where you could get clear air, and I think it was maybe due west.
Right.
And it's like one of the more infrequent directions you would get during that time period.
That was a really interesting, very short period of time, because most of the smoke that we got was from the northeast of the immediate Seattle area, coming through the Fraser Valley and across the Cascades. And then that it was up toward Haida Gwaii, I believe, and up in that region. And we got a northwesterly wind, and it drove that smoke right down from northwest to southeast. You could not have chosen a better direction for wind to get that smoke to come right into western Washington, right into the Seattle area. Had it been 10 degrees one way or the other in direction, it wouldn't have been a big deal. And it was funny because we were anticipating and we were telling people, okay, the smoke is going to get better. And it didn't.
Yeah, exactly.
The wind shifted and it didn't.
I think I remember.
Yeah.
Well, do you guys use the HER smoke model much at all, Morgan, when you guys are forecasting smoke? So I hadn't heard of that before this year, and I think it's just a fantastic resource.
It worked very, very well this year. And my pick of the week is actually the Blue Sky USDA model that uses NAM and some of the others. But the high resolution HER for smoke was very, very effective this year.
I actually haven't heard of the Blue Sky one, so I'll check that out.
Yeah, it uses GFS and NAM and several different forecast models. It's been around for a little while.
Mm-hmm.
Oh, yeah.
Hey, guys, let me call a timeout real quick here because I've got to go do some television. We're going to take a quick break. We have to interrupt Morgan for Morgan, which for those that don't know, the pipes you're hearing on the Tony Rice segment, that's actually Morgan doing the intro here. So, Bill, I'm going to roll Tony's report for this week, and I'm going to go do some television, let you pick it up. I love this show. I've learned more by listening to you guys. And I can't wait to hear the rest of this. But we're going to take a quick break for Tony, and we'll come back with picks of the week and much more as WeatherBrains rolls along.
Looking beyond the atmosphere, here's Tony Rice with your astronomy outlook.
You might have seen somewhere that if Earth were 10 feet closer to the sun, we'd all burn up. 10 feet further away, and we'd all freeze to death. As claims go, you'll be hard-pressed to find one more wrong than this. In fact, assuming you're listening to the WeatherBrains live, Earth has moved about a mile closer to the sun, just to the time it's taken you to listen to this podcast. If you're listening a week later, it's more like a 100-mile difference. Go out a month from now, and the Earth-Sun distance will be growing by nearly 600 miles each hour. So fear not, Earth's habitable zone is quite a bit larger than your local Facebook scientist would have you believe. The Earth-Sun distance varies by about 3.4 million miles each year. Tonight, January 2nd, a few seconds after 11:20 p.m. Central, 12:20 a.m. Eastern, and so on, Earth will be at perihelion, a mere 91.4 million miles from the Sun, the closest point in its orbit. That's right, we're the closest to the Sun at winter, at least here in the Northern Hemisphere. We'll be the furthest, July 3rd, aphelion. Some have wondered, might this explain the record temperatures being seen this week in Australia? Well, it is true that sunlight falling on Earth is more intense at perihelion than aphelion. The effects of the sun's proximity are negligible. According to Roy Spencer of NASA's Global Hydrology and Climate Center in Huntsville, averaged across the globe, sunlight falling on the Earth in January is about 7% more intense than it is in July. The fact that the northern hemisphere of Earth has more land, while the southern hemisphere has more water, tends to moderate the impact. That's your astronomy outlook. Follow me at RTP Hookie for more spacey stuff like this.
And I think, Dr. John, that Tony is going to be the next Jack Horkheimer, don't you think?
I love his stuff. It's fantastic.
It's getting better every week too.
Yeah,
and that guy that does the voice at the beginning, that's incredible. So you were mentioning, Dr. John, that the car fire might have been started by a spark from an automobile.
Yeah, we've been talking about
the wildfires as much as I wanted to tonight because we just ran out of time. But
we could do an entire show, Bill, on wildfires, and then also on some of the modeling that's being done in the short term to forecast where those plumes are going.
We could do a month-long series, I'm sure.
Yeah, right.
Morgan, you should start a local WeatherBrains there in Seattle. It sounds like you got more weather than all of us put together.
It was, it is an interesting area in which to forecast. We have a lot of very smart people, a lot of very weather-interested people up here in the Northwest, even though a lot of people think our weather is boring. Now, I will say this place lights up no pun intended. We'll say Twitter lights up. There's one lightning strike.
Yeah.
People go nuts. And before I moved to Seattle, I have family up here, so I'd visited a lot of time in the summer, not in the season when we would get activity like this. But I came from Southwest Florida, where 4,000 lightning strikes in a typical couple of hours in the afternoon was a normal summer's day. And so it's really interesting. We just don't get much convective activity up here. When it does happen, especially a few weeks ago with the Port Orchard tornado, and to actually see an area of low CC right after that tornado touchdown, wow. And that was something that I would never have thought I would actually see up here.
Yeah.
Is a tornado debris signature on correlation coefficient like that up around 5,000 feet.
Wow.
It was amazing.
So take us through that day for a second. How were y'all covering it?
It was it was a typical convective afternoon, and our storms. This thing had a top, I think, around 25,000 feet. These are low top storms, and they will rotate sometimes. A lot of times from shear in the atmosphere, and also there can be some low level enhancement because of terrain, and certainly that played a role because this was Port Orchard, not too far away from the Olympics. There was some enhanced vorticity there that caught, and it happened so quickly. Although going back and looking at the radar, the area of the couplet, if you will, wasn't as pronounced and as strong as areas in the plains in the southeast. But as Cliff mentioned earlier, it was there and it was stronger than we typically see. But we do see it sometimes, and so nobody was on the air doing any sort of extensive severe weather coverage. We don't have severe weather up here. This was a very unusual event, a once in a decade, once in 2 decade event up here in the Northwest. And it happened very quickly.
Yeah. You sometimes get really weak tornadoes, like say an EF0 or an EF1, especially affiliated with those Puget Sound convergence zones, because you have a lot of horizontal shear with the northerly and southerly winds coming, but you don't get that really strong vertical shear with light winds or, moderate southerly winds in the lower atmosphere and then strong southwesterly winds coming off the desert like you do over the Great Plains. So the shear that we get here is generally horizontal instead of vertical, so that precludes those really strong storms and those really strong that really strong shear from occurring.
Yeah, I was going to say there's an event from history, the April 5th, 1971 tornado that went through Portland, Oregon, and Vancouver, Washington, so across the Columbia River. And I believe that might have been an EF3.
Yeah.
In fact, it directly hit an elementary school in Vancouver.
Wow.
And it was associated with all kinds of characteristics of severe weather. It was golf ball sized hail from the thunderstorm.
Vancouver.
There were, through the Willamette Valley, from about Corvallis northward, there were strong straight line wind gusts, upwards of 60 to 65 miles per hour. Associated, it's almost like a squall line went through. It's almost like a Midwestern style squall line, and that maybe stands out. This one stands out as the benchmark, severe local storms type of event.
Absolutely. And that's Vancouver, Washington, not Vancouver, BC. Some folks get confused, I think, sometimes, especially if they're listening to this. Vancouver, Washington is basically just north of the Columbia River, just north of Portland.
Yeah, I should have had y'all all get out your National Geographic Road Atlas.
Two Vancouvers we're talking about.
Following along. Aubrey, you can't leave.
I have to go to stupid TV.
Tell them to delay the show. They delay it all the time for football.
I know. What a great show, guys. It was good seeing you all. Good stuff.
Great stuff.
Have a great night.
Take care.
So yeah,
we had a big severe thunderstorm outbreak like that back, I think it was May 2017. There was you were probably pretty busy that day, but there's a big microburst over Thurston County knocked down a bunch of power lines and some trees. There was golf ball sized hail with many storms. I think they measured cloud tops with a supercell over Skamania County at over 40,000 feet. There may have been a tornado warning in somewhere in eastern Oregon. There are severe thunderstorm warnings throughout, and lots of lightning, of course. So we can occasionally get strong to severe thunderstorms around the area, but the combination of since the Pacific is really acts as a moderator with regards to severe weather. You need a really moist lower atmosphere, and Pacific is 55 degrees tops during the summer, at least the coastal region of the Pacific. So we generally do not get the high humidities. You can get and we did get that on May because we had a ridge of high pressure over our region, but we also had an atmospheric river that was sending precipitation mainly into northern Vancouver Island, but it was still sending a lot of moisture, low level and mid level moisture into our region. And then we had an upper level trough in the upper atmosphere that had cooler temperatures. So you had lots of low level moisture, and with the ridge of high pressure and the May sun, you had warmer temperatures and then a good lapse rate due to the upper level trough coming in and decent wind shear as well. So that was more of a typical severe thunderstorm scenario with all the ingredients you'd expect out of something in the Great Plains. But again, most of the stuff we see, cloud tops 15, 20,000 feet, actually 25,000 feet, as Cliff was saying, is pretty impressive for and it's something that people will just laugh at.
If Cape hits 1,000 here, our antenna's up. You know, it's okay. That's significant. If we have a 4-digit Cape here,
we're kind of finding that in the Southeast too. I mean, a lot of our events are happening in those, lower Cape environments, 1,000, 1,500 joules.
Well, as long as you got the shear.
I heard like 2,000 to 3,000 with a lot of helicity is the sweet spot, rather than just having these giant 7,000 or 8,000.
And it's so interesting because the tornadoes that so many of us have studied over time have those huge photographs, but also gigantic Cape, and getting these little skinny Cape, high shear tornado events that I think before Doppler radar, we would have missed a lot of those. And now we're catching a lot more of them. And the one thing that we didn't mention, we were really flying blind up here until I think it was late 2011 or early 2012 when we got the coastal radar. And Cliff Mass actually had a lot to do with spearheading getting that coastal radar on the South Washington coast at Langley Hill operational. Because the Portland radar, if you just look at the footprint of the Portland radar and what we call the Seattle radar at Camano Island, look at the footprints of those two radars. We were blind, absolutely blind off the coast until we finally got the Langley Hill radar. And it has been absolutely worth its weight in meteorological gold up here for us.
Oh, absolutely.
So
Morgan, I kind of have a bit of nostalgia of seeing V.
Well, we had it a couple of weeks ago. It went down.
Really?
I don't remember which event it was, but it was down for a good 6 to 12 hours, and it was during my shift. And I had to tell people,
oh man,
I ended up putting up water vapor. Trust me, there's something out here.
I know, it's amazing how you become the something once you have it, right?
Right.
Yeah.
So Morgan,
it's been a huge help for sure.
What's the blob and what's its impact on your weather over the course of a season?
Well, we've had the blob, and then we had blob 2.0. Generally, just warmer surface water in the Pacific Ocean. A few years ago, 2 or 3 years ago, it was very pronounced, and it occurred when we had a significant long period of ridging over the East Pacific, Northeast Pacific, and we just didn't get much in the way of upwelling and storm activity to come through. And one thing it did, as far as our weather goes, we were very tranquil during that period and warmer than normal. In fact, we've had some very warm years over the past 4 to 5 years. We just ended our 4th. I'd have to go back and double check and confirm, but the early numbers that I ran, we ended up in Seattle our 4th warmest year on record when you look at daily average temperature, and 4 of the past 5 years have been in the top 5. And so some very significant changes in our weather up here. But what it has done, unfortunately, to the fisheries, the shellfish industry in particular, has been very hard hit along the Pacific coast because those mollusks need very specific water temperature, and then you get into salinity, and all sorts of things change when the water temperature changes. And migration, by the way, of whales and orcas farther north, and other types of fish. There was a very interesting article in the Seattle Times a few weeks ago on that, and the changing fisheries, and how fisheries that are based in Seattle have to change and redeploy operations to different locations because what they're catching is now not what they used to catch for decades and decades and centuries.
Well, I remember going fishing in Puget Sound. We like to go fishing there in 2014, summer of 2014. And all the fish we were mainly catching coho salmon, but they're usually around 8 or 9 pounds, nice ocean fish that are coming into the rivers to spawn. These fish were around 3 pounds. That was the average size. And I don't think we ever caught one that was bigger than 5 pounds. And I'm presuming it was because of the blob. There was very little mixing of the ocean due to that ridge of high pressure over the region. And the reason why the water was warm is because of that lower mixing, and you had the sun heating the surface. And the blob was also associated with fairly sterile waters, so not much feed out there at all. And that's why I'm assuming the salmon were so small. No, there was also a large bird die-off around on the Washington coast. I'm not sure if that was related, but potentially it's also due to a decreased food source. And this is unrelated to the blob, I think, but there's sea star wasting disease, and that started also along the Pacific coast. But it could be because it occurred at around that same period and coincided with the blob. So a lot of marine effects from the atmospheric features.
Well, I'll add that this may or may not be as directly related to the blob, but our unusual summer windstorm in 2015 occurred during the period when the blob was active, and also right in the middle of a massive El Nino, which is counterintuitive to the local lore that El Nino years tend to have fewer windstorms than neutral years or La Ninas. But we had a significant wind event on August 29th, and it's very rare to have high winds anytime during the summer here. And so, but it stood out to me that, the blob may have had something to do with that, but one would have to do a much more detailed analysis than just associating the two events. And but what interested me, particularly about the August windstorm with regards to the blob, is that it brought with it unusually warm temperatures for an extratropical cyclone, even in summer. So when we get a rain event in the summer, the temperatures still cool off considerably. Like we'll get rain and it'll be in the 50 degree range, maybe low 60s in the summer. And during that windstorm, we were seeing temperatures in the mid 70s. And I still state that it's the warmest windstorm we have on record. I haven't found one that's produced warmer temperatures. So I think there's something going on there. El Nino, blob, warmest windstorm on record, and in the summer.
Interesting.
But it'd take much more analysis than I've done to actually connect those pieces.
So Dr. John, didn't our friend Miles Musio, didn't he come up with an index for the that he was doing a paper on at NWA about that sort of stuff? Maybe we'll have to have Miles on. I think he
I don't remember
that.
What he was using.
You remember, Morgan?
I remember, and I don't remember what it was called.
Well,
I remember him presenting.
Miles on to talk about his index.
It wasn't Windex, was it?
It probably was. That's probably exactly what it was. Dr. Reed, I know you have to go. You've got a family member to pick up at the airport. Anything you want to make sure we cover before you leave?
No, I think I would definitely like to talk about big snow events.
Yeah, that's next on my list. Amazing snow events.
We've had a number. I'll throw one in from history here before I head out, and that would be the the infamous January 1880 snow event, which happened at the same time as the big windstorm in the Willamette Valley. They're all part of the same storm train. And from limited analysis that I've done, I've seen that my guess is that snowstorm, and there was actually several combined, that built up the snows to unbelievable levels. But there was one event where there were claims of 2 to 4 feet in one day in and around the Seattle area. And I can only think that was an atmospheric river that had very cold air on the north side of it. It was backing it, and it caught the precipitation. You can find photos of this. At some point, I intend to actually do a much more thorough analysis of that event. And actually pin down exactly how much snow really fell for specific storm systems. But one figure I do remember clearly was a measurement of 54 inches in Tacoma.
I can't even fathom that. Way off the chart.
Measuring it in feet
these days.
1 to 3 inches sends the city into a complete frenzy.
A shutdown, absolutely.
Shutdown, yeah.
What would 1 to 3 feet do?
Right.
Yeah, that's right.
So, Dr. Reed, where do our folks go to access all of your information? Dr. John shared one of your cool graphics there from one of your papers. Where can they find more?
Yeah, there's 2 websites. The one he was using was the Storm King. And you know, if you just do a Google search, Storm King Pacific Northwest, you're likely to find it. That has my repository of windstorm information that I periodically update. There's been a delay for a while since I've last done it, but I do come in and update from year to year. Then I also keep a blog that's called Coquitlam Weather and Climate, and it's mainly focused on Southwest BC, but I bring in Northwest Washington because we share a common heritage. And we'll definitely discuss Oregon when the weather gets interesting down there in the blog. But that's the one that's most constantly updated. It's got the most recent stuff of mine on it, including a posting on the recent Solstice Eve windstorm, the 20 December windstorm. It's a post that's half done. I'm still working on it. There's still further analysis to go.
So, Dr. John, I know you have a weather bucket list, some events you'd like to go and experience. So I'll ask Dr. Reed before he leaves, you know, if you wanted to come up here and go through one of these storms, what would be the perfect safe place to come and experience one of them on the coast or close where you could get the full effect?
Oh, full effect of one of our coastal storms?
Yeah.
A great place to go storm watching would pretty much anywhere on say the Oregon, Washington, or BC coast. One of the places I like is called Tofino, Tofino, on southern Vancouver Island. Now there's a place to watch Pacific storms come in. I've seen some monsters. You can get extremely heavy rain combined with gale force wind gusts, and it gives you the full effect of a hurricane. You know, just sitting in the car watching it lash the coastline. So that's one area what I'd recommend. If you're interested in measuring really high wind speeds, it's like what Charlie was talking about. You go to the Columbia Gorge during a gap wind event, and then you can get pummeled by 100-mile-per-hour wind gusts.
It's just sunny and cold and windy.
Yeah, exactly. Cold, windy weather.
That's interesting, Wolf, because we like to go up to Tofino in the summer to go fishing, and of course there are those storm watching trips that they have, and I never really thought. I was like, okay, you know, anywhere you go on the coast has to be good for the storms, but I guess Tofino's better than other areas.
It's a good, you know, because you're, you know, being that far north, you're often in the storm track.
Yeah.
You know, and I just recall I was there for one storm where, I mean, the rain was coming down so hard that even on these steep roads, it was a solid sheet of water just pouring down, and there's all these rocky cliffs on the way out. I'm sure you know the route.
Mm-hmm. Oh,
there were like waterfalls coming down where there shouldn't be waterfalls. There's just
yeah, wow.
then you add 50 to 60 mile an hour wind gusts to that, and it was just crazy. It was crazy weather.
Yeah.
Sort of in between whenever we have a wind event, we send our crews out to ocean shores.
Yeah.
Sort of on the south coast of Washington. It's readily, well, I say readily accessible. It's a hike. It's a hike from Portland and from Seattle to get out there. But that's a good spot, good viewing area, and I think a lot of people go out there. I've actually never been out there myself in a big storm, because whenever there's a big storm, I've got to be parked at work.
Yeah, right. Well, I'm going to write all these down, Morgan. All these.
Some
places.
people will go to Cape Disappointment. They have a lighthouse up there.
That doesn't sound like that's a good place to go.
I know.
The coast is beautiful. Yeah.
Don't get disappointed, of course. But I've seen some really cool pictures of waves crashing against the shore, and they have a lighthouse up there. It's always interesting to see how high the spray gets and if it touches the lighthouse or not.
And often these days, the weather station that gets the worst of the wind whenever we have, say, a Western Washington windstorm or a Southern BC storm is Destruction Island.
Yeah,
right along the central coast, but it's a bit offshore.
There's
a weather station there, and you'll get the top wind gust right there at Destruction Island.
Yeah, that's right.
Easy to remember.
Yeah, and then Western Oregon, it's Cape Blanco.
Cape Blanco, yeah.
Southwest Oregon. That is the place for high wind gusts down there. They hold the. I can't remember what's the estimated gust for the Columbus Day storm there.
I've heard multiple estimates. I heard 179.
Yeah, something like 179.
I also heard a gust of. I heard sustained 145 with gust to 179 from the Portland National Weather Service. I also saw something of like 195.
Yeah.
Either way,
and by the way, that was on a damaged anemometer that only had 2 cups. From what I understand.
It's been fascinating to have you on the show tonight. Well, thank you so much.
Glad to be here, and again, thanks for having me on.
How can people get in touch with you if they want to contact you?
They can get my email off the Storm King website.
That's how I did it.
Yeah, the best way to get me is by email for sure.
Yeah,
and
that's awesome.
I was rating that site earlier. That's right.
Well, that's awesome. Well, thank you for joining us tonight, and good luck at the airport tonight. I hope your flight's on time, and hope you have a great rest of the week and weekend. And we'll talk to you again real soon.
Yeah, you bet. Thanks a lot. Thanks for having me on the show. I loved it.
It was awesome. Yeah, we'll call you up next time there's a big storm, and we'll meet you at Cape Disappointment or
that's right.
Camp Destruction or whatever these places.
We'll all get together.
We'll do the show live there. Thank you.
Thanks, Will.
All right, Charlie. I wanted to make sure we talked to you for a minute about your energy forecasting, and I'm probably butchering all these names after Morgan just does them so effortlessly. But there was one place I wanted to ask you about, and the Catitas Breezeway. How badly did I do with that? Catitas. All right, Morgan, don't laugh at me now.
It's all right. Catitas. So Catitas Breezeway. I haven't done any forecasting for there, but I'm assuming that's the Wild Horse Wind Farm that you're talking about, Morgan. Yeah. That area. So
I think so. I would imagine it would be over in Kittitas County, which is east of the Cass, or basically along Interstate 90. I'm not exactly familiar with it completely.
Yeah. So most of our wind farms in the Pacific Northwest are positioned to take advantage of summer diurnal gap winds. Kittitas, what was it called again? The Kittitas Breezeway?
Yeah, that's the word I saw. Yeah.
Kittitas Breezeway. I've never actually heard that term before, but it makes a lot of sense. And they are probably, even though they're not in the Columbia River Gorge where a lot of the other wind farms are, the Kittitas Breezeway, if it's where I'm thinking it is just outside of Ellensburg, is in central Washington, is one of the better places in the entire state for as far as wind generation goes. Because they get a combination of afternoon and evening diurnal winds in the summer. The central Washington heats up, pressure lowers, you get that onshore pressure gradient, and the onshore winds fill in. But they're also pretty isolated from other terrain. So during the winter, when you have storms coming through, they're not sheltered like some of the lower elevations of the Columbia River Gorge are from wind speeds that are coming through. The problem that you get a lot of those gorge sites, especially ones that have super low elevations, is that in the winter, when the Columbia Basin really cools off, you get a strong inversion and you get really low temperatures, below freezing temperatures. Not only does that lead to low winds, but you can get icing on the blades of the wind turbines and just no generation whatsoever. So if you're in the Kittitas Breezeway up on those mountains, you get above that and you still get the diurnal wind impact. That's a pretty good combination as far as wind production goes.
That's amazing stuff. I know, Dr. John, you're getting sleepy over there because even though these guys are ready to go out and party for the night, it's getting late over here in the East.
Yeah,
it is. It is.
Late.
So, Dr. John, we'll start with you for picks of the week. We'll go past the weather roundup tonight and just go straight.
Okay, Bill. Well, I went back and forth on this. There's so much good stuff out there, but I just have to go with the shutdown in Washington and the impact that that's going to have on all of us in the weather enterprise. It's just driving me crazy. You know, the consulting work that I do, I can't access the archives anymore because they've shut them down.
Yeah.
So that's my pick. It's an article in the science section of the Washington Post, and it's entitled "Disruptive, Disappointing, Chaotic Shutdown Upends Scientific Research."
Just ridiculous. Ridiculous. All right. Charlie, can you throw a pick of the week our way? I didn't warn you about this.
No.
It's the foghorn.
Like, I didn't know I had homework.
Yeah.
Well, the view of the Willamette was pretty nice today. Unfortunately, sorry, I don't have any. I didn't take a picture.
That's all right. There was some pass because you were such a great contributor tonight.
There was some beautiful steam fog walking to work this morning. It was real nice.
Walking to work. That makes me so jealous. Do you get to walk? You don't get to walk to work because you have to go across Lake
See if you can paint the picture. You're walking along the Willamette, which is not that pretty during the day, I might add. It's just completely brown. Portland's not known for the tail end of the Willamette's not known for its pristine water quality. But just walking to work in the morning and seeing some lights around, the steam fog off the Willamette, it was really pretty.
Yeah, because you were mentioning your sunrises are awfully late and sunsets awfully early, right? This time of year, Morgan.
Yeah, our earliest sunset in Seattle is 4:18. The sunrise, what is it, 7? I'd have to look that up. But we to begin winter, on the first day of winter, we have 8 hours and 25 minutes of daylight in Seattle. First day of summer, we have 15 hours, 59 minutes of daylight.
Wow.
Huge difference. And it starts to really play on you. The really cool thing about the spring, though, as we're heading toward the equinox, we're gaining more than 3 minutes of daylight a day.
Mm-hmm.
Yeah.
And so over about a week's period, it's nearly an extra half hour of daylight. And everybody starts to brighten up because everybody notices it. It's really amazing being this far north and getting that sort of variation.
Is the seasonal affective disorder really a real thing?
It is. It kicks in about this time of year after the holidays when we have a day like today, which was gloomy, and you're driving outside at noon, and if it's cloudy, your headlights are going to come on automatically. It's just that dark. Mm-hmm. Our sun angle in Seattle's the minimum on the solstice is about 18%.
Mm-hmm.
Wow.
Yeah.
Well, I'm sorry, 18 degrees. 18 degrees is the sun angle.
So Morgan, I'm sorry. Go ahead.
At least for me, all of us meteorologists love the big storms, right? And those generally occur in especially November and December for us. So once you get past Christmas and you get into January, you can still get some storms. We had the Inauguration Day storm in 1993. But most of them are over, and you just have this slow trudge towards spring. And if you don't have anything else to do, like I love to go skiing. And I think that's a great way to try and beat the seasonal affective disorder blues. Just have something to do outside, because the Pacific Northwest is fantastic if you don't mind getting wet. But if you let the weather take away all your opportunities and prevent you from getting outside and enjoying yourself, then you're just going to have a miserable time here. So, yeah.
Well, fortunately, we like rain. So,
that's good.
Morgan, pick of the week.
I've got to actually recycle one from the last time I was on WeatherBrains, and it came to mind after I checked two other websites. One was the High Split Trajectory website, got a government shutdown splash screen, and I don't remember what the other one was, but it was a government shutdown splash screen. So we'll go with the Blue Sky. It's the Airfire Blue Sky smoke forecasts, and it models wildfires across all of the country, not just the West, and uses different forecast models, the NAM, the GFS, I think the Canadians thrown in there, and then some other forecast models, some high res, some global models to depict where the smoke is likely to go. So that's the pick of the week. I guess I threw that out there about 2 years ago. It's good enough to be recycled. It's a good website.
Anytime you want to come back, Morgan, we'd love to have you. My pick of the week is Dr. John's Christmas card. It just came. Dr. John. Dr. John's beautiful family.
Oh, Bill.
There. Isn't that wonderful? Where was that picture taken, Dr. John?
Seneca Lake, New York, Bill.
Wow. That's
the
awesome.
Finger Lakes.
All right. Have we covered all the business, Dr. John? I never know. Is there anything else we had to do? Did you get your pick of the weekend?
Yeah, I sure did. Yeah.
Okay, good.
The shutdown.
You got any more business before this august group tonight?
No, we have our own atmospheric river working towards us again, Bill.
Oh Lord, yeah, we're in an atmospheric bog, I think, down here. So maybe it will end at some point. Well, guys, y'all made this just a fantastic show. I'm so thrilled that we got y'all on board. Morgan, thank you. Charlie, thank you so much.
You bet. Good to be here.
And
great stuff, guys.
And we'll see you somewhere at a conference soon, Morgan. I'm sure. Hope we see you too, Charlie. But WeatherBrains is the weekly netcast. It's all about weather. We usually do it on Monday nights. Now that we're past the holiday season, we'll go back to a regular schedule. Yours truly will not be here next Monday night because my Alabama Crimson Tide will be playing for a national championship Monday night. So I will not be here, but we're going to have a great amateur radio show. Scott Martin from my team has put together a group of folks that will be here to talk about amateur radio, and James will be in charge because he's, just not that big of a football fan. So anyway, but until next Monday night when all the rest of the group gets together, as I always tell you, keep an eye to the sky because you'll always have something fun to look at. So again, thanks everybody. Dr. John, thanks for staying up late.
Thank you, Bill. Take care now.
All right.
Morgan, thank you.
Good to see you.
Thank
So
you.
long.
Bye, guys.
Have a good night.
Oh, yeah. It was amazing. People are still watching this. Love the show tonight. Of course, I don't get to hear the whole show. You know, it's kind of strange in that every Monday night or whenever we do the show, I have to leave this room and go into the TV studio to do the job that I'm paid to do. And I miss part of the content. But in a way, it's kind of fun because I listen to the show when I'm driving. You know, I drive to school programs, and I drive a lot during the week. So I listen to podcasts, and I listen to this one because so often I'm busy and doing things, and I just miss some of the really good content here. And having this crew tonight was just fantastic. Great to have Morgan and Cliff Mass and Dr. Reed and everybody on the show tonight. So that was good. And it's great to listen and learn about other parts of the country as well. Just finished a Song of the Night on Instagram. I'm Span WX. If you ever want to watch that, we do that every night at about 10:20 Central Time. And that's nothing but having some fun. Kind of getting back in the swing of things here. We went to Colorado again. If you listened to the pre-show, and had a lot of fun out there. I've never been skiing in the Colorado Rocky Mountains before. That was the first. Went to Snowmass, 12,000 feet, and a lot of fun. And that was a hoot. And actually met a few WeatherBrains listeners out there, which was kind of fun. But next week we'll be back on the Monday night schedule, and we should be good for Monday nights for a while. I know that for you college football fans, it's national championship night, Alabama and Clemson, but a lot of you don't have much interest in that. So we'll be here. And then again, we know most people listen. They don't necessarily watch live. They'll watch later or listen later. So thank you guys for being around tonight. We'll see y'all Monday night of next week. Have a great week. Thanks for listening and watching. And